Okay, guys, let's start. So, first of all, good evening, curious minds. A warm welcome to all the first timers and a big shout out to the patrons of Curious Minds community. I thank you all for your interest in science. Today, we are discussing science behind memory and tools to improve it. It is important to understand the basics of memory in order to understand learning and change. As always, I will start with the presentation and then the meetup will be open for questions and discussion. Just a reminder, this Meetup Zoom session is being recorded and tomorrow I will upload it on my YouTube channel, the link of which will be shared in the Meetup chat. So in today's talk, we will understand the science of memory, how memories are formed in the brain, different learning strategies to improve memory, and how to spot normal versus not normal cognitive decline. And stick to the end to learn about Memory ToolKit, where I will share the 5 tools to improve memory and brain health in general. I promise to make it all clear and accessible, regardless of whether or not you have a scientific background. Before that, let me introduce myself. I am a cancer immunologist. I write 2 newsletters which are free to subscribe, so please do check them. Recently, I've started a science book club on Meetup, and this month we will be discussing Gabor Mate's The Myth of Normal, Trauma, Illness, and Healing in the Toxic Culture. It will be an online event held on February 24. Now, before going into memory, I just wanted to share the Curious Minds community's YouTube channel page, and so please subscribe and share with friends and family. I'm uploading every meetup sessions which we have till now on this page. So now let's learn about the biology of memory. Memory is the process of taking in information from the world around us, processing it, storing it, and later recalling that information sometimes many years later. When we learn something, even as simple as someone's name, we form connections between neurons in the brain. So in this picture, you can see how the neuron looks. So this is a graphical representation on the left, and this is how it looks under a microscope. So neurons or nerve cells are the fundamental units of the brain and nervous system. They are information messengers. So they use electrical impulses and chemical signals to transmit information between different areas of the brain and between the brain and the rest of the nervous system. So within a neuron, the nerve impulse moves to the tip of an axon. So here, this is the axon and it moves towards the tip of the axon and causes the release of neurotransmitters or chemicals that act as messages. So this is one neuron and this is the second neuron, and this is a picture of 2 neurons talking to each other. And this crosstalk or this talk of neurons is called synapse. And this is how a connection is formed. So whatever messages you are taking from the outside world, they are being recorded in your brain in form of synapses. So as you are listening to me and seeing these images, billions upon billions of electrical impulses are flying through your brain. In a complex symphony of activity, all those impulses are somehow encoding your thoughts, feelings, and understanding. So there are about 85 billion neurons in a typical adult human brain, and about 10 quadrillion connections or synapses between all those neurons. That is a 1 followed by 16 zeros. That's like amazing. And that is just the neurons. So there are about 86 billion non-neuronal cells. So the image here, these are the cells which are non-neuronal, but they are also helping in forming the connections. So they are also helping in the forming memories or the connections or synapses in the brain. So this is all the white matter. So neuron, where the neurons are, it is the gray matter. Why it is called gray? Because it looks grayish under the microscope. And the white matter, where these cells reside, the non-neuronal cells reside. And both the white matter and the gray matter are actually important to form memories and to form connections. So synapses get stronger or weaker depending on how often you are exposed to the event. So now let's take a look into how we process the information into a memory. Information comes in through our senses, our ears, eyes, skin, nose, or taste buds. The information gets encoded only if you are paying attention. Important thing to note here. So, attentive information gets routed either through the low road, that is the amygdala, the emergency flight and fight emotional memory storage center, or the high road, hippocampus cortex, or the memory storage center. So, hippocampus is the major memory retention center, and amygdala is also records the emotions. So, in case of a flight and fight response, your memories are generally recorded in the amygdala, which is the fastest response memory storage center of our brain, and hence called the low road. And the hippocampus called cortex center is the one which is recording the memories for long term, and it takes little time for that memory to be recorded, and hence it's called high road. And once information comes in, it needs to get encoded. So if you want that information to be encoded in the long term, you need to write that language. So you need to have these neuronal connections. And lastly, we call back our stored information. We have to locate the information in our brain and return it to our consciousness. So, we humans have different types of memories. Let's understand what they are. So, sensory memory, which allows individuals to retain impressions or sensory information um, after the original stimulus has ceased. So, one of the most common examples of sensory memory is fast moving lights in darkness. So, sensory memory is not involved in higher cognitive functions like short term and long term memory. So, it's just like for a fraction of seconds, for example, 3 seconds, you will have that memory in your brain. And then it is the short term memory. Short term memory is also known as the working memory. For example, it can hold only few items. For example, if someone tells you their phone number or a certain digits, so you are holding that in your memory, and it is like very short, only for 30 seconds or 20 seconds. And it is shown that you can hold around 7 plus or minus 2 items in your short term memory in general. And however, items can be moved from short term memory to long term via processes like rehearsal. And long term memories are all the memories we hold for periods of time longer than a few seconds. And long term memory encompasses everything from what we have learned in first grade to our old addresses to what we wore to work yesterday. And it has incredibly vast storage capacity. As you have learned the number of neurons and the number of synapses these neurons can form, so we can retain a lot of memory in the long term centers. So long term memory can basically divide it into two different types. One is explicit or declarative memory, and the other is implicit. So what is explicit memory? This memory requires conscious recall. It consists of information that is consciously stored or retrieved. So, explicit memory can be further subdivided into semantic memory, like facts taken out of the context, such as Paris is the capital of France. So, this will be your semantic memory. And episodic memory are some personal experiences which you store. So, in contrast to explicit, or declarative memory, there is also a system for procedural or implicit memory. So these memories are not based on consciously storing and retrieving information, but on implicit learning. Often, this type of memory is employed in learning new motor skills. An example of implicit learning is learning to ride a bike. So, you do not need to consciously remember how to ride a bike, you simply do. This is because of implicit memory. So, this is the different types of memory. Now, let's move forward and understand like which part of brain is actually responsible for which type of memory. So, if we will think, uh, there are different regions of brain for storing different kinds of memory. So short term memories are processed in the prefrontal cortex, which is also responsible for other complex cognitive functions such as decision making. And explicit long term memories are stored in the hippocampus. So, if you see this brain structure, I promise this is the last slide of science of memory, and then we are going into the fun part. So here, a hippocampus is one, which is hippocampus, neocortex, and amygdala. These three are responsible for your long-term memories. And so hippocampus will store your episodic memories. The neocortex will store the semantic memory, and the amygdala connects memories to emotions. And memories connected to strong emotions like love and fear are harder to forget. Then now you can understand whenever you feel very emotional to certain conditions, or you are feeling certain strong emotions, you will not forget that memories very soon. And that's why in case of PTSD, the memories are stored so deeply inside and they come up again and again. So, if you are more interested to learn about the science of trauma, I have uploaded the slide on the YouTube channel, the whole meetup session. You can go there, or you can join us in the Feb 24 book meetup. We will be discussing all about trauma and how to heal from trauma. So, now let's shift gears and discuss different learning techniques, strategies to improve memory. So this is the comprehensive list of 12 principles of memory. So which includes selectivity, association, visualization, elaboration, concentration, recitation, intention. So I'm not going into the details of all the 12 principles. In today's talk, I will be focusing on three crucial learning tech strategies, which will definitely help you to move information faster from your short term to long term memory. And that's what we need. We need to enhance our long term memory. And these memory strategies are urgency, repetition, and association. So let's start with urgency. So, urgency is when there is the release of stress hormones. It creates a powerful wash of chemicals that strengthens the connection between neurons or synapses. And as we understand in the science of memory, we need these strong connections to have that memory retention and long term memory centers. And urgency also determines how and when the brain encodes the information into long term memory. This is important to understand. Urgency can create a very long lasting memory after even a single exposure to a threat. The amygdala can retain the memory for an entire lifespan. However, the encoding or labeling of the event, that is the ability to recall or retrieve the memory, can be more troublesome and not under conscious control. This thing happens with PTSD. So, for example, I can pass by where I had my car accident and get anxious, even if I don't have a conscious memory of the event, because the amygdala has stored that response so strongly in the brain that it will come up and you will feel the same kind of emotions which you felt at the first time the event happened. So, the other form of urgency is when faced with mild stressful situations such as exams, deadlines, or interpersonal conflicts. These are situations where we are under mild stressful conditions. And so, while stress around the time of learning is thought to enhance memory formation, thus leading to robust memories, stress markedly impairs memory retrieval. Also, stress may hamper the updating of memories in the light of new information and induce a shift from a flexible cognitive form of learning towards rather rigid habit like behavior. So it is important to understand that stress under stressful situation, like we procrastinate and we wait for the deadlines and then we work. And then we feel that we are working on an adrenaline rush and we could work faster. But this kind of working habit is actually, it is like habit learning. But as soon as you are doing, the body is under stress, You are doing the task, you are thinking you are doing better, but you are not actually. When you will recall the event, like how you performed, how you did that activity, you will not be able to recall the event, and you will not be able to learn from the task you did. So you will work like a machine learning, like a machine. You will not be having a human experience, or you will not encoding the memory of it. So this is important to understand that under stressful conditions, our exam results will be bad. And so repetition. So repetition is an essential learning aid. It allows a conscious skill to transfer into one's subconscious, freeing up working memory and allowing for further skills. So repetition is one form of learning, and the other form of learning is cramming. So cramming is essentially trying to stuff load of information into your short term memory in time for an upcoming exam. We all have been there when we have to cram a lot of things, and we do it. We go to the exam, we write an exam. Sometimes we can recall most of the part, and it gets we can recall it, or we give the exam, come back, and the next day we forget everything. This is what happens with cramming. So because it is just retained in your short term memory and it has not formed connections, so it will just get lost. uh, you need to have a format of learning. So repetition helps in that. So the memories in your brain become stronger through repeated spaced study sessions, which is what spaced repetition is all about. We will talk about spaced repetition in a while. Before that, look at this graph, which is Ebbinghaus forgetting curve. So in this, you can see the first one, this blue line here, tells you that when you learn something, your memory retention within weeks, it goes down. So if you are not repeating the action of your learning, in about 4 or 5 weeks, you will completely forget about it. But if you are like spaced recall, if you are practicing this spaced repetition, and after 1 week you go back and repeated the same activity or learned again, then your retention time is much longer. The If you are doing it for the first week and the second week again, so like this, if you are recalling, if you are repeatedly learning, you can retain it for a longer time, and in a while that memory will form a long-term retentions, strong neural connections, and you will remember it for forever, like if you are recalling it in spaced times. So in brain talk, it can be said that neurons that fire together wire together. So neuropsychologist Donald Hebb first used this phrase in 1949 to describe how pathways in the brain are formed and reinforced through repetition. So now what is spaced repetition? So repeatedly encountering material at a spaced interval is more effective than reviewing the material multiple times in the same study session. These are the three things for especially for students or for people who have difficulty. Like if you are learning some new technique or learning some new lesson and you are finding it difficult, break that down into small break the study material into small segments, and then go to that uh, via practicing this spaced repetition technique. The third is association. So association and learning can be well explained from Pavlov's classical experiment, where he found that dogs could learn to salivate at the sound of bell. uh, so Pavlov's classical experiment, everyone has heard about it. If you have not, it was that he used to ring a bell and give food to the dog. So the dog used to associate food with the sound of the bell. So even if he was not giving the food, uh, only by ringing the bell, the dog used to start salivating. So this is the association learning technique. And there are like mnemonic strategies, five different types of mnemonic strategies, which can be easily applied into learning, and they work wonders. So if you want to learn something very difficult, it's very easy to break it down and associate it with something. So it can be music mnemonics or name mnemonics, for example, VibGyor. So if you want to learn the different colors in the spectrum, in the white light spectrum, VibGyor is the very easy way to learn. So it will be violet, indigo, blue, green, yellow, orange, red. So you don't have to learn the whole order. Just remember this and it is in your head every time. So name of expression mnemonics, it's like my very educated mother just served us nachos. So it is the name of the planets in the order. So Mars, Venus, Earth, so Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Like this, you can learn. So these are the different forms which are very important for people who are doing a lot of learning new subject, or for anyone. It's very important, very easy. This is the link to the PDF where you can find like all the details how how they have given with different examples. So now the stimulation from urgency, repetition, or association will actually create new proteins inside your neuron at the level of the synapse. So this is the two neurons. This is the unstimulated synapse, and this is the stimulated synapse. Stimulated synapse means when you are doing this repetition or association, then you are making these neurons, like a lot of proteins are formed in this first neurons, which are chemical messengers for the second neuron. So in this stimulated synapse, you are forming strong connections between the two neurons, and this will be long lasting connections and will help you to retain the matter which you have learned for a longer time. So repetition actually grows the brain's neural network. So repetition is the best way to learn. And from childhood, we have learned that repeat things and you can learn faster. So now let's shift gears again and to recognize how normal and not normal memory decline is. So there is 6 types of normal memory lapses which can occur to anyone, and there is no need to worry. And they occur because of reason, because you are not paying attention. There is no original awareness. Like I mentioned before, if you are not attentive, you will not form the connections. And second is blocking. It usually occurs when several memories create a disruption. Scrambling, so when confusing with the little details. So fading away when you are not recalling the memory, so it will fade away. Struggling for retrieval is the same. Muddled multitasking, when we are doing multitasking, so we are not actually retaining anything. It we think that we can multitask, but results have studies have shown that multitasking doesn't work. So in both of the tasks, you're not creating long term memories, and it will not benefit in you long term. So these are the normal decline which can happen with anyone, which can happen to anyone, and there's no need to worry about it. These doesn't mean that you are having a cognitive decline or any kind of neurodegenerative disorder. So what is not normal? So with early dementia, one of the first things that people will notice is difficulty retrieving the details of events, asking the same question over and over again, getting lost in places a person knows well, like address to the home, the directions to your home, or directions to your place of work, having trouble following recipes or directions, becoming more confused about time, people, and places, and not taking care of oneself, eating poorly, or not bathing, or behaving unsafely. So these are the signs which are, uh, if you are seeing in your loved one or your people around you, then these are the signs of cognitive decline and not normal. And it's the time to talk to your doctor about it. So now brain fog or memory loss. So brain fog is characterized by confusion, forgetfulness, and a lack of focus and mental clarity. This can be caused by overworking, lack of sleep, stress, and spending too much time on the computer. The other medical reasons can be inflammatory conditions like multiple sclerosis, autoimmune disorders like lupus, asthma or allergies, anxiety, depression, cancer treatments. In some cancer treatments, you will feel brain fog. Then hormonal changes, we will talk about this. Then chronic fatigue syndrome or certain medications. But recently, we have heard about this brain fog related to long COVID. So, brain fog or cognitive dysfunction is one of the common post COVID symptoms. For some people, it lasts for few days, but for some, it lasts for months. So, what COVID does is it lead to vascular damage, and due to low oxygen electric dysfunction and some neurotransmitter disbalance, the brain fog occurs. But the good thing is it is curable. We can work on it and it can be cured. So I will talk about how the different things in the fourth segment of the talk today. And then we have this midlife brain fog, where sometimes it more occurs in females because of hormonal changes. So during the time of pregnancy, when the estrogen hormone is low, then you feel this momentarily brain fog or lapses in recollection. And during menopause. So during menopause, your estrogen levels are going down, and this is commonly referred to as midlife brain fog. And this can be easily treated with hormonal therapy. So, nothing to worry about, just to know that these things will occur around certain time of the your lifetime. So, you have to work on it. But the not normal things, the not normal points are important to understand. So now the types of cognitive decline. With normal age, the brain functions decline. Uh, After around age 40, the hippocampus, which is the memory center, it shrinks by about 0.5% per year. And the shrinkage is quite variable among individuals and heavily depends on individuals' lifestyle choices, environment factors, and genetic predisposition. So there's a normal zero point 0.5 decline, but you can have a little control on it. And how you can do it, we will soon talk about it. And so other cognitive decline things is dementia, which includes Alzheimer's, vascular dementia, dementia with Lewy body, and frontotemporal lobar dementia. We will talk about all this neurodegenerative disorders in the April meetup. So now, Memory Toolkit. So these are, I will talk about simple lifestyle modifications which can be easily incorporated to improve the memory function of brain. So what is this Memory Toolkit? It has 5 pillars: move, discover, relax, nourish, and connect. So the first one is the movement. It is shown that physical activity is the strongest evidence to date to positive brain changes. So here in this graph, you can see that up till about age 70, we are not getting slower. So our muscular functions and our strength is actually, we can retain it up till 70 years of age. So this is like the normal aging thing happens. After the 70, our muscular decline will happen rapidly if we have not worked well before. So if you have to see less cognitive decline, better brain health, you have to start working from your age 30 or 35 before 40. So low intensity activities like walking, gardening, or ballroom dancing can be beneficial more than we previously realized. So these small physical activities also can help. It's not just you have to go to gym and do strenuous physical activities that will count. These small activities also count. The idea is just to keep your body moving, not sit for too long, not stand for too long. You have to keep moving. So the actionable advice will be to mix up to regular physical exercise for at least 150 minutes a week, and mix it up with interval and strength training. So interval training means you alternate between varying levels of speed, intensity, and effort. Think of it as surprising the body so you don't fall into the well worn ruts that fail to challenge the body and lead to plateau in your progress. So, this is important, challenging your brain with new activities. And strength training is refers to use of weights or just your own weights as resistance. This will help you to build muscle mass and tone and help balance and coordination. So, while exercising won't completely prevent or cure normal cognitive decline in aging, doing it consistently can help reduce or delay the onset of it. In many ways, exercise is like a supercharged 401k for your brain, and it's even better because it's free. Exercising brain is another way to stay mentally fit. If your regular daily activity of work is primarily left brained, so your left brain is thinking or logical side, then switch to doing some right brained activities. So the right brain is more of your creative center tied to the creation of music, art and imagination. So and vice versa. If you are more doing right brain activities, then do some left brain and vice versa. So this is to exercise your brain. The second important pillar is the power of purpose, learning, and discovery. So you can't cash on your educational degree if you haven't been keeping up with your continued education in the form of reading, learning, and socializing. Use it or lose it is the concept for memory. So if you have to build a build a strong cognitive reserve for active aging. You have to build brain resiliency, and this can be done by continuously learning and continuously discovering new things. So, reserve is a reflection of how much you have challenged your brain over the years through your education, work, and other activities. Cognitive stimulation increases the density of neurons, synapses, and dendrites. Dendrites are the connections which are formed, multiple connections. So, when you have long term, then the first neuron is forming multiple connections with the second neuron, not just one, and the strong connection is built with multiple dendrites, and it helps to build a brain resistance. And it's it's why you see when two people are fall into the some disease, they both have a different recovery duration. This is because the one person has built a strong brain resilience, it will recover faster from any kind of disease, and the other, if the person has not built a good memory, a brain resilience, the process of healing will be slower. And thus it is important to keep on learning, have a curious mind to things, and just build more neuronal connections in the brain. The third is the need for sleep and relaxation. So, sleep affects almost every type of tissue and system in your body. So, it's your brain, your heart, lungs, metabolism, immune function, mood, and disease resistance. Everything is controlled by sleep. So, when you are sleeping, your brain is actually performing the cleansing function. It clears itself from the debris. And this process is actually recently discovered, and it is called the glyphematic system. So, if you are sleeping badly, if you are not sleeping well, if you don't have a strong deep sleep in while you are sleeping, so you will not be getting rid of this debris formed in the brain. And then it the because Alzheimer's is because Alzheimer is caused because of the amyloid plaque, and this amyloid plaque can be just flushed out from the system with a good night's sleep. So sleep is very important. I will be elaborating on sleep, science of sleep, and tools to improve it in an upcoming March 1 meetup. So if you want to learn, do sign up for that. Now the fourth pillar is the food. So avoiding an entire food group or restricting certain foods is not an ideal approach. And research studies show that mind diet, which is the Mediterranean and the dash Dash is the dietary approaches to stop hypertension. So mind diet is good for delaying cognitive decline. So diet also plays an important role, and recently there are a lot of studies right now which are making this correlation between the diet and the cognitive decline, and more studies are needed, and there is no um, good paper right now to quote, but these are the studies, the upcoming studies which are showing that there is a relation. And so the one thing which I can mention here is, if you are having this cognitive decline or brain fog, you can check, or COVID related brain fog, you can check your vitamin B12 labels and can have a diet rich in vitamin B12 or a supplement which can help you with the brain fog. So now, very simple thing, follow the sharp way. What is sharp way is S stands for slash the sugar and stick to your ABCs. A is a list of foods you consume daily. So fresh vegetables, whole berries, fish, seafood, healthy fats, nuts and seeds. For to be simple, just the Mediterranean diet. And the B is the list of foods to include, and C is the list of foods to limit. So fried foods, whole fat dairy, high in saturated fat, sugary foods, processed foods are the foods to be avoided. H stands for hydrate smartly. A is add more omega-3 fatty acids and dietary fibers. And then R is to reduce portions, small food, intermittent fasting. And P is to plan ahead your meals so you don't end up eating processed foods or the frozen foods. The fifth pillar is the connection for protection. Recent studies show that loneliness and social isolation plays an important role in maintaining brain health and help in memory function of the brain. So there is a recent paper which showed that social isolation was associated about 50% increased risk of dementia. So this is also the important thing, connection. And yeah, there are many papers now relating the connection in the food thing to the memory decline. Now I will end this with the book recommendations. And this book we discussed in our February book meetup. Oh no, in the Gen we discussed Wendy Suzuki's Healthy Brain and Happy Life, and these are the books which you can refer. The S.H.A.R.P method was discovered by this Dr. Sanjay Gupta, and he has discussed it in detail in his book. And the Diet for the Mind, which was the one which I was discussing before. So now I thank you all. And if you want to connect with me or you want to email me, you can send me here. And now it's open for questions and discussions. So I have one in the Meetup chat. So what you can do, you can write me a question in the Meetup chat, or you can unmute yourself and ask me there. So I already have from Jim. How do we determine if the memory loss is temporary or some form of a permanent decline that needs more serious attention? So, Jim, what I told in the not normal and normal are the few things which you can go through again, like to know which one is normal and not normal. And the other thing is